get started. Welcome back, everybody. It's really awesome to have you guys here on our very last lesson about functions and relationships. This is going to be an application type lesson. It's going to be a little bit more difficult than the other things that we've been doing, but I'm going to help you and support you the whole way through it, so don't worry about that. Now, unfortunately, we have had to disable the chat. Okay, and what that means is that you guys cannot put anything in the chat where you communicate with one another. And unfortunately, we've had to make this decision based on the fact that some people were not doing as we had asked repeatedly. Okay, so we've had people making rude signs, making ugly comments, and basically being very disrespectful to the learners that are here, and we feel it's disrespectful to us as well. So we have decided that we're going to have to change things. And unfortunately, as if behavior improves, then we will be able to go back to the system that we had before. And if it doesn't, then we'll have to stay the way that we are. So the only way that you have of communicating now is by raising your hand and then asking to speak. So we can't post anything in the chat. You are welcome to ask questions naturally. And what I would like to ask you to do is to direct your questions to Kat, okay, because I'm going to be busy teaching. All right, so if you have got a question or something that you're stuck with, Kat is there and she's going to help you. All right, and what I'm going to try and do is obviously something a little bit different. I'm going to call on people and I'm going to ask you for answers or how you think we should do things. And we're just going to try this structure out for today. Okay, all right, so let's get underway. Let me just move this. Hang on 1 second, there we go. Okay, so our last lesson on functions and relationships. So we've all seen flow diagrams before, right? In this case here, what I wanted to give you an opportunity to practice was determining the rule. Okay, so you've been given a set of input numbers and a set of output numbers, and the first two are really quite easy, but questions 3 and 4 and 5 and 6 are a little bit more challenging. All right, so let me just see who's here with us. Okay, so now the first person that I'm going to call on is Asimahle. Asimahle, do you know how we would work out what the rule is in question number 1?
Ma'am, I'm not really sure, but
okay, so you can see when 1 goes in, 5 comes out, and when 2 goes in, 11 comes out, and when 3 goes in, 17 comes out, when 4 goes in, and 23 comes out. So is this an arithmetic pattern or is this a geometric pattern? Were you with us, Asimahle, when we did geometric patterns and arithmetic patterns? Okay, Asimahle, don't worry. Devon, what would you do here, Devon?
ma'am, I would times by 6 and minus 1.
You would times by 6 and minus 1. Now, that is the right answer, but I want you to tell me, how did you get that answer and how did you do it so quickly? What did you do to work that out?
Ma'am, I was trying to see which numbers could like which numbers I could times and minus and add by to get the answer, ma'am.
Okay, so what you're supposed to be doing is you're supposed to be looking at the difference between the outputs. Okay, so when you go from 5 to 11, you add 6. When you go from 11, you've got to add 6 again to get to 17. When you're sitting at 17, you've got to add 6 again in order to get to 23. So 6 becomes your multiplier. All right, if we say 1 times 6, because that's our first input, we get 6 out, but we don't get 6 out, we get 5 out. And that's why we had to say 6 minus 1 to give us 5. Okay, and then we would have tested our rule and we would have said, okay, 2 times 6 is 12, 12 minus 1 is 11. Oh yes, we've got that right. And then 3 goes in, 3 times 6 is 18, minus 1 is 17. And that's how we know that we are correct. Remember, these are arithmetic patterns. They all have a common difference. Okay, all right, Rolivua, do you want to do number 2?
Yes.
Go for it.
Is it times by 3, add 3?
Okay, that's not what I got, but I could have made a mistake. Let me write down what your answer is. So you are saying times by 3 and add 3. Okay, so let's test what you're doing here, all right? If your rule is true, then 3 times 2 gives us 6. And then I've got 6, and now I need to add 3, and I get 9. Oh, goodness, I don't get 11. Okay, so timesing by 3 and adding 3 is not going to work in this case. Let's see if there's 3. That's fine, Rolivua. Do you want to try again?
Is it maybe times by 3, add 5?
Okay, so what you must always check for first, Rolivua, is the difference, the constant difference. Okay, so look at the output numbers. This one is 11. The next one is 15. The next one is 19. The next one's 23. What is the difference between 15 and 11?
4.
4. Okay, what's the difference between 15 and 19, or 19 and 15, should I say? It's also
4.
4. Okay, and again, if I say 23 minus 19, I get 4.
4.
So now you've got to take your input numbers and you've got to times them by 4. So if you look at the first one, Rolivua, 2 goes in. Okay, so 2 goes in. 8 times 2 is, sorry, 4 times 2 is?
8.
8. And now what do you need to add to get to 11?
3.
There we go. Whoopsie, I'm in the wrong pen. Good. That's nice, Rolivua. Do you see this is how it's supposed to work? And then if you test the next one. So 3 goes in. So 3 goes into your rule. 3 is here. 3 goes in. So 4 times 3 is?
4
12.
times 3 is 12.
Good. And 12 plus 3 leaves us with?
15.
There we go. Okay, you see how it works now?
Yes.
Okay, all right. Let's see if there's someone else. Okay, Buhle, will you try number 3 for us?
Oh, ma'am, I'm still calculating.
Okay, I'll go on to somebody else then, Buhle. That's fine. Luyanda, can you do number 3?
Luyanda's mic is not active. So
okay. Oh, yeah. Sorry, that's silly of me. It isn't active. Patson. Hello, Patson.
Hi, ma'am.
Can you do number 3, Patson?
Yes, ma'am.
Okay, Patson. What is the rule in the case of question number 3?
It's times 3 minus 6.
Times 3 and minus 6. And how did you work that out, Patson?
Ma'am, I looked at the output numbers and I found out the difference. And then I went to the input numbers, ma'am. And then I calculated the differences with the inputs, and then I wanted to see what was subtracting or what
you needed to add.
Yes, ma'am.
Good, Patson. That's really good. Well done. I got the same answer as you for number 3. I also got times by 3 and then take away 6. Good job. Very nice. Okay, Devin, your hand is up next. Do you want to do number 4, Devin?
sorry, Lee, you have to unmute them. Sorry, I'm getting there. There we go.
Oh, sorry. Sorry, beg your pardon. Sorry, Kat. Can Devin?
I was zoned out for a minute.
Okay,
yes.
All right. Devin, you can do number 4.
Ma'am, it is times 9 minus 8.
Wow, you are really good at this, aren't you? That is amazing. Well done.
Well done.
Y equals 9 and then minus 8. Absolutely. So hopefully what you looked at here is you said 19 minus 10 is 9 and 28 minus 9 gives me 19 and 37 minus 28 also leaves me with 9. Okay, so the difference becomes our multiplier, and then we have to substitute and then check where we need to add or subtract in order to get the correct output. Nice, good job, well done. All right, excellent. Let's see who else we can call on here, someone who's got an active mic. Okay, what about Eli? Eli, can you do number 5?
I'm not sure, ma'am.
You're not sure? Okay, come, let's do it together, okay? All right, this is a difficult one, and I don't blame you for being a little bit confused. That's why I gave you guys these questions, because they are a little bit harder, okay? What you need to do is you need to look for the inputs that are in a row, that are, Kat, help me here, I've lost the word. What's consecutive? There we go, I've got it. That are consecutive numbers. Do you know what the word consecutive means, Eli?
No, ma'am.
Okay, so the word consecutive means that one thing follows another. So if I said to you, Eli, give me 3 consecutive numbers, you could say 1, 2, 3. Or we could even work with negative numbers. So for example, I could go -3, -4, -5. Those are 3 consecutive negative numbers. Does that make sense to you? So they follow one another.
Yes, ma'am.
Okay, all right. So now some numbers that are consecutive that follow one another are these inputs over here. All right, so we go from -3, we add 1, we get -2, we add 1, we get -1. These are our inputs, all right? So if we have a look at the difference in the outputs between these 3, it can tell us what our constant difference is. All right, so in other words, we go from 16 to 14 to 12. Right, so what's happening here? Are our numbers getting bigger or are they getting smaller?
Bigger.
But if it's gone from 16 to 14, has it got bigger?
Smaller.
It's got smaller, hasn't it? And by how much has it got smaller?
2, ma'am.
Exactly. So what we've done is we've taken away 2, haven't we? Okay,
Yes,
and it's the same with the next one. We have taken away 2. Now, just like how we're showing all the others, all right, these numbers over here, all right, these constant differences, this becomes our multiplier. Okay, so now what we have to do here is we've got to take our input numbers and multiply them by -2. So what we do is we write our rule like this: output y equals -2 times input. Okay, so now you've got to see what it is that you're supposed to add or subtract. Okay, so if -3 goes in, like it does in the first case, we're going to take -2 and times it by -3. That means that we're going to end up with an answer of 6. But we don't end up with an answer of 6, we end up with an answer of 16. So what do we need to plus to 6 to get to 16? Eli, what would we add to 6 to get to 16?
10.
10, exactly, perfect, 100%. So now, do you think you can tell me what the rule is?
10, ma'am.
Okay, the rule is take your input and times it first by negative 2. All right, and then after that, you need to add 10. 10, that's it. Okay. All right. The next one is also a difficult question. All right, let's see who's got their hands in the air. No one right now. Okay, Patson, you've got your hand up. Do you think you know how to do number 6, Patson?
Yes, ma'am.
Okay, go for
while
it.
you're busy explaining number 5, ma'am, I was trying to figure out what's the next one, ma'am.
Oh,
So
okay.
what
All right.
I got -3. I mean, I got like input times -3 minus 1.
Okay, I didn't get that, but I could have made a mistake. All right, but you and I have got the same numbers. We've just got different signs. Just give me 1 second.
Ma'am, no. It's a positive because it can't be a negative. Ma'am, if it was a negative,
okay. Why can't it be a negative?
It's because 2 negatives, they equal a positive.
They do when we multiply
And
them
the
together.
outputs are negatives only.
Absolutely. No, you're quite right. Okay, so I'm going to show you what I think I got.
Okay. Yes, ma'am.
All right, so this is what I did here. All right, so again, we're looking for inputs that are consecutive, ones that follow one another so that we can see, excuse me, what our constant difference is, right? So they've change things around here because now we've got -2 and then it becomes smaller and it becomes -3 and then it becomes -4. So if we were looking at this in a table, it would be -4, then -3, then -2. Those are our inputs. Our outputs would be, for -4, it would be -11. Then it would be not 18. I'm going mad. Not 18, guys, just 8. And then our next input is -5. That's another way for us to be able to look at it. So if we look at these numbers, like you were saying, Patson, when we go from -11 to -8, our numbers are getting bigger, aren't they? Okay, -8 is closer to 0 than -11 is. And -5 is closer still to 0 than what -8 is. So these numbers are getting bigger. So there is a positive first difference. Nathaniel, I see you've got a hand up. What did you want to say, Nathaniel? Nathaniel? Don't know where Nathaniel went. Okay, Nathaniel, if you do want to say an answer, you're very welcome. All right, so in this case here, our constant difference is +3. So that means that we have to take our output, and in order to get output, we have to multiply input by 3. But that's not the whole story, okay? Because if we take 3 and we times it by -2, we end up with -6. But that's not what we get out. We get out -5. So now what do we need to do to -6 in order to get an answer of -5? Okay, Patson says we've got to -1. Let's see what other people are saying. Tolana, what do you think? Do we have to put -1 here? Is that right?
Yes, ma'am.
Okay, but if I take -6 and I -1, all right, does that mean I'm going to end up at -5 on the number line?
Yes.
It doesn't, unfortunately.
It will be 7.
Okay, it would be -7, wouldn't it? Okay, because I'm sitting at -6 on the number line and I'm moving one place to the left. So I'm not going to end at -5. I'm going to end at -7. And that's not the number that's sitting there. I've got -5 sitting there. So minusing 1 from -6 is not correct. Boutle, do you think you know what the correct one is now? The correct thing is to do.
Yes, ma'am.
Okay.
It would be 3 times +1.
It would be Boutle. Well done. That's very good. Okay, quite right. So we're going to take our input numbers, times them by 3, and then add 1. Very good. Okay, and that was because when we had our -6, when we plus 1, then we end up at -5. Okay. All right, sorry, I'm just having a look at some of the messages here. Okay, well done, grade 7s. That's really good. Okay, well, hopefully those gave you, well, some of you at least, a little bit of a challenge. Let's have a look at, maybe we won't do all of these. Maybe we'll just do one of them, and then we can move on to something else. Boutle, I see you've got your hand up. Do you want to say something?
Ma'am, wait. Oh, okay. I think I got the answer for number 1.
Okay, you mean the number 1 that's on the screen at the moment?
Yes.
Okay, all right, go for it. What did you get as your answer?
Ma'am, you for the answer it is you'll be +2 because -4 to get to -2 you have to +2, and then to get to 2 you also have to get to
Okay,
0
so
you also have to +2.
you're right,
Wait.
Boutle. So what that means is that your constant difference is 2. And remember, your constant difference becomes your multiplier.
Yes, ma'am.
Okay, so what are we timesing input by?
You're timesing input by 2.
Good, lovely. So we're going to take input. So like 1, for example, and we're going to times it by 2, and that gives us 2. All right, but do we get 2 out when 1 goes in? When 1 goes in, we get 0 out. So how are we going to get back to 0? What are we going to take away?
You're going to take away 2.
Lovely. 2 minus 2 is 0. Lovely. Now test and see whether your pattern works for the rest of the numbers. So test 3. So 3 goes in, times it by 2. What do you get? Boutle, you get?
You get 6.
You get 6. And then what do we have to do to 6 to keep our pattern going?
So you have to -2 also.
Lovely. And do we get the correct output when we do that?
Yes, ma'am.
Yes, we do. Okay, lovely. Well done. Very good. That's nice work. Okay, now let's see. We've got some other hands up. Indanako, I'm glad to see your hand is up. Indanako, can you do number 2 or number 3?
I'll do number 2.
Sure, go for it. What do you think, Indanako? What do you
think
get for number 2?
you minus 3.
You
No, you
minus
add 3, sorry.
You add
plus
3 each time, quite right. Okay, so when I go from there to there, I've got to add 3 and then add 3 and then add 3. You're quite right. Is that all? Is that all I'm doing is just adding 3? What do you think my rule for input and output has to be? What do I do with this 3? You have to take your input and you have to times it by 3. Remember, becomes your multiplier. Your constant difference becomes your multiplier. Okay, absolutely. And now you're going to go and test and see, okay, well, when 1 goes in, so 3 times 1 gives us 3. Do we get 3 out when 1 goes in?
No.
No, we get 6 out. So now what are we going to do to 3 to get 6?
You add 3.
Lovely. Okay, so now let's test to see whether your theory works for all of them. Okay, so now 2 is going to go in. So in Denako now you've got 3 times 2.
2, which
What
is
does that give
6.
you? And now what must I
6,
do to
and then you
6?
say 6 plus 3, which will give you 9.
Okay, so is the pattern working now?
Yes.
Oh, that's lovely. Why don't you test just one more? What happens when 3 goes in? What should I write here?
3 times 3,
Yes.
which will give you 9. Then you say
Mhm.
9 plus 3, which will give you 12.
Okay, and that's indeed what you get over there. All right, so when 3 went in, we got 12 out. That was lovely, Endanako. I would
Thank
really love to
you.
hear from you more often. That was great. Well done. You got that one right as well. Okay, so times by 3 and add 3. Lovely work. Very, very nice. Okay, so now let's give somebody else a chance to talk that hasn't spoken before. Zinhle. Zinhle, do you want to talk about number 3, please, Zinhle? Okay, Zinhle, maybe you can't talk right now. Nathaniel, can you tell us what to do in number 3, Nathaniel?
Ma'am,
Yes.
ma'am,
Yes, Nathaniel.
do you minus -3, ma'am?
Okay, let's just rub this stuff out of the way here. All right. So Nathaniel, you are saying that when we go from one term to the next, we're minusing 3. Okay, I don't think it can be 3 because if we're going from -3 to -9, if we're sitting at -3 and we take away another 3, that would get us to -6.
Yes, ma'am.
So what we're taking away is a little bit bigger than 3. Right, so you know what you can do, Nathaniel? You can use a number line to help you here. All right, so if I draw a quick number line, okay, and over here I've got -3, then -4, -5, -6, -7,
Ma'am?
-8. Yes, Nathaniel, you think you figured it out?
Is it -6?
That's it. Okay, now you are smoking hot. Okay, and if we're sitting at -9 on the number line and we take away another 6, we're going to get to -15. All right, and if we're sitting at -15 and we take away another 6, we're going to get to -21. Excellent. Okay, Nathaniel, are you ready
Yes,
to
ma'am.
slay the beast?
I don't know, ma'am, but yes, ma'am.
Okay, what should I write, Nathaniel?
Ma'am, y
Yes.
equal sign.
Mm-hmm.
Ma'am, is it that x, ma'am?
It is, and then what do I have to do to my x?
Ma'am, then you have to say times 6, ma'am.
Times -6.
-6, ma'am. Yes, ma'am.
That's it. Lovely. Okay, but is that the whole story? Does input go in and then we times it by -6 and we get our answer?
No, ma'am.
No. What do we still need to do?
I don't know, ma'am.
It's okay. So Nathaniel, if you have a look when 1 goes in, you're going to say 1 goes in, I times it by -6, I get -6. Except you don't
Yes,
get
ma'am.
-6, you get -9. So now you have to
-9,
take -6. And what are you going to do to -6 in order to get -9?
Times it, ma'am.
You're not going to times it. You've got to add or subtract now. You've got to take away
3, ma'am.
That's it. Okay. And now you can see, are you on the right track? So you take your next input, Nathaniel, which is 2.
Yes,
2
ma'am.
times -6 gives you what?
12, ma'am. -12, ma'am.
-12. Lovely. And then what do we need to do to -12, Nathaniel?
You minus it, ma'am.
You minus 3. Okay, and
Yes,
then where
ma'am.
will we end up? If we're sitting at minus 12 on the number line and we take away 3, where will we end? At
9.
At negative 15. You're going in the wrong direction. Okay, so if you're sitting here at negative 12, I'm going to show you now. Oh, sorry, I left out negative 13. That's not very clever. All right, so now if I was sitting at negative 12 and I want to minus 3, minus means I've got to go in that direction where numbers get smaller. So I'm going to hop 1, 2, 3 places to the left. Okay.
Yes, ma'am.
All right, well done, Nathaniel. That was really good. These are difficult questions. All right, so I'm just reminding you all again that they are supposed to be difficult, but I think you guys are doing super, super well. Okay. All right, let's move on. Okay. Now I've got a more challenging question for you. All right. Here, there are numbers missing in the table. And you guys need to work out what the missing number is. All right, so the letters that we need to calculate the value of are A and B. So I'm going to show you what happens with the first one, and then I'm going to let you think about what we do in the second one. In fact, maybe what I should do is do the second one with you, because I think that's a little bit more difficult. And then maybe you can have a choice of doing the first or the third one. Okay, so again, you need to look for input numbers that are consecutive, that follow one another. All right, so your input numbers that follow one another here are 0 and 1 and 2. Or even minus 1 and then 0 and then 1 and then 2. So now look at the difference between the outputs. From here to here, we added 2. From there to there, we also added 2. From here to here, we also added 2. So that means that 2 has to be our multiplier. So that means that we're going to take our output. In order to get our output, we're taking our input and we are timesing it by 2. Okay? But minus 1 times 2 gives us minus 2. It doesn't give us 9. Okay? Minus 1 times 2 gives us minus 2. We're now sitting at minus 2 and we want to get to 9. So what are we going to do to minus 2 in order to get to 9? We have to add 11. Buthle, you had your hand up. Did you want to ask a question or say something?
Ma'am, I forgot to lower my hand. I wanted to answer the previous questions.
Oh, okay. All right. That's fine. Okay. Kabo, I see you've got your hand up. What's wrong, Kabo?
I do not understand anything.
Oh, goodness. When you say you do not understand anything, where did I lose you?
By number 2.
Okay. So do you want me to go back and just talk about how we would work this out?
Yes, please.
Okay. All right. So let's go back to number 2 here. Okay. You have to work out the rule for these input and output numbers. Okay. So it's the same idea that we were doing here, where we had a flow diagram, only now we're working with a table. The problem here, though, is that there are numbers missing from the table. Okay, so that number there is missing and that number there is missing. Okay, but if you have a look, you go from minus 1 to 0 to 1 to 2, then you jump to 7, then you jump to 15. Okay, so you don't know what comes out when 15 goes in, because it doesn't follow 14 and 13 and 12 and 11 and 10 and 9 and 8. All of those have been left out. So in order to work out what comes out at A, you have to work out what the rule of the pattern is. Okay, we need to work out the rule for the pattern. So we've been doing what we were doing earlier. where we have to look for input numbers that follow one another so we can see what the difference is between the terms. So that's why I'm looking here at -1, and then 0, and then 1, and then 2. Those are the only 4 numbers in my input row that follow one another. 7 and 15 do not follow one another. So now I can look at the corresponding outputs, and I can see what comes out when these numbers go in. So when -1 goes in, 9 comes out. When 0 goes in, 11 comes out. When 1 goes in, 13 comes out. When 2 goes in, 15 comes out. And I have to work out the difference between these outputs. So what am I adding each time? To go from 9 to 11, what must I add? Kabo, what must I add?
Teacher, I think you add, let me just see. Maybe, let me just check here. Is it 11? No, and then 2. I think you add 2.
You do, that's right.
Yes,
And then
teacher.
what, okay, you're quite right. And then what do I need to add to 11 to get to 13?
You add 2.
Exactly. And what would I add to 13 to get 15?
You also add 2.
Okay, so now that's what we call our constant difference. Okay, so there is a constant difference between consecutive terms of 2.
Yes,
That's
teacher.
the number that we have to multiply our input by. So we take our input number, so like -1, and I have to times it by 2. What do I
Yes.
get out? When I say -1 times 2, what do I get out?
-1 times 2. Maybe -2.
That's quite right. But do I get -2 as my answer in the table? Is that -2? No,
Yes.
it's not. No, it's not. The one that I
Oh.
just drew the orange circle around, that is 9, isn't it?
It
All
is
right.
9.
Exactly. So now I've got to take -2 and I've got to do something to it so that I get 9. So what can I do to -2 to get 9 out?
Mine, it can maybe be, teacher, can teacher just give me 1 minute?
Sure.
Teacher, isn't it -12? -2 plus 12?
Okay, you're very close. You're very, very close. So -2 plus 12 will give you 10.
Oh, -2 plus 11.
Ah, that's it. Good job. Okay, now we're getting somewhere. All right, now, Kabo, we're going to do the next one. We're going to take 1. 1's going to go in, okay? So our input number, we're now looking at these two over here. Okay, that I've just drawn a pink circle around. So 1, what must I do to 1? I've got to times it by
2.
2, and I'm going to get?
Sorry, teacher?
So if I say 1 times 2, I'm going to get an answer of?
2.
Lovely. And then I take my 2, and what do I need to add to it?
You may you add 2 not 2 man 11.
Good. And what are we going to get out?
9.
2 plus 11? We're going to get?
Oh. We're gonna get 13.
You're going to get 13. There you go. Can you see? Look there. 1 went in and 13 came out. You made that happen.
Yes, teacher.
Okay. Does that make more sense now?
Yes, teacher.
All right. So now you're going to help me answer question A. All right. We need to work out what comes out when 15 goes in. Okay, what I'm highlighting in pink here, when 15 goes in, what comes out? So can you tell me what to write? What do I have to do to 15?
1 times 2.
So 15 times 2.
Should I say the answer, teacher?
You should, yes, please.
30.
Lovely. And then I'm going to take 30 and I'm going to do what to it, Cabo?
You're going to plus it.
With 11. Good. And what are we going to get out?
We're going to get 41. I'm not sure about the answer.
That is wonderful, Cabo. Yes, we're going to get out 41. Excellent. Well done. Does that make more sense to you now?
Yes, teacher.
Okay. All right. That's lovely. Okay. No problem. All right. Just give me 1 second. I just want to write to someone in the chat. Just give me 1 second. Okay, all right, now, let's see, okay, Anati, I see you've got your hand up, Anati. Did you want to ask a question?
Yes, I was confused on number 3.
Oh, you mean with question 3?
Yes.
Okay, we're going to get to it. I'm going to explain that one to you now. There's still something in question 2 that we need to do. Okay, before we go to question 3. So just hang tight, okay? And then we'll get there and then we'll go and we'll talk about it. I just want to ask, okay, Devin, I'm going to ask you. Oh, hang on a second, that wasn't clever. What would happen here, Devin, all right, in the very last column?
Ma'am.
Hang on a second. So this question over here, sorry, Devin, I don't mean to interrupt you. So now you don't know what the input is. You've got an output of 91. How are you going to work out what number went in? Do you know how to do that?
I do not think so, ma'am.
Okay, all right. So what we've got to do here is we've got to reverse the process, right? So now when they give us, okay, we've got to work backwards, okay? So remember, like, I don't know if you guys played the game Pass the Parcel when you were younger at birthday parties, but when I was a little girl, that's what we used to do. So imagine if somebody had wrapped up a present and first you put red paper on the present and then you put blue paper on the present. Can you take the red paper off first, grade 7s?
Yes.
How?
I mean,
you can't take the red paper off first. You could only take the blue paper off first and then the red paper underneath. Okay, so do you understand what I'm saying? So if you've taken it and you've wrapped it in red and then in blue, and now you want to unwrap the present, you first got to take the blue paper off and then the red paper. Does that make sense? So we have to reverse this process. Okay, so our process is times by 2 and plus 11. So the reverse of that has to be the opposite. Okay, so the opposite of plus 11 is?
divide 11. I mean minus 11.
Minus 11. Okay, and the opposite of times by 2 is?
Divide.
Divide by 2. Lovely. So now we have to start at 91, our output, and we take away 11. What will we get? Devin will get?
80.
Ah, lovely. And now we've got to take 80 and we've got to divide it by?
2.
Lovely. So that gives us?
40.
Beautiful. Okay, and now you worked out what went in. Okay, I think that's really cool. Well done. That's lovely. Let's just see. There's a couple of things in the chat. Okay. Now, what I'm going to do is I'm going to give you guys an opportunity to see if you can do A and B on your own. So just have a look at number 1. And then we're going to talk about it in 2 minutes. So see if you can work out what the rule is, and then what A is, and then if you really can, what B is. Okay, I'm just going to message someone. Tolana,
Can I do number
1.
1? Yes.
Sure, are you ready?
Yes, ma'am.
Okay. All right. So the first thing that you have to do is you have to tell us the rule.
The rule is +1 +2 +2 and times 1.
Okay, so I've got a first times by 1. So I'm going to take, let me write it over here. In fact, sorry, Kat, I'm just going to delete you quickly. So Tolana, you are saying that our rule is times by 1 and plus
2.
plus 2. All right. So in other words, you are saying output can be calculated by taking input, timesing it by 1, and then plusing 2. Let's see if that works. Okay, so what I'm going to do is let's test number 1. Let's test what happens when 1 goes in. All right, so 1 goes in, we have to times it by 1. What do we get as an answer? Tolana, we get?
We get 2. Wait.
1 times 1 is not 2.
1. We get 1.
We get 1, absolutely. And then you said we have to take 1 and we have to add 2 to it in order to get our output. So if we have 1 and we add 2, we get 3. But are we getting a 3 out here?
No.
No,
Wait.
we're not. So part of your answer is right and part of your answer is wrong. Do you think you know where you can
Oh, yes,
correct
it's
yourself?
+4.
Ah, well done. That's excellent. Well done. It is +4. Good, Tolana. That's lovely. It's really nice if you can correct your own work and see where you've gone wrong. That's brilliant. Okay. And now what I want you to do, Tolana, is I want you to take another input number. Okay. So take 5 as your input. And just test to see if your pattern works again. So 5 goes in. What must we times it by?
1.
Good. What do we get out?
We get 5.
Beautiful. And then what are we going to do to 5?
+4.
Absolutely. What do we get out?
9.
Excellent. Do we get 9 out over here?
Yes.
Yes, we do. Okay, very good. So now you're going to tell me what happens when 13 goes in.
When you add, you multiply it by 1.
Good. Keep going.
And add it by 4.
Good. And what are you going to get out?
17.
Hey,
Wait.
you're too clever. Well done. That's very nice work. Well done. So we've worked out in this case that the value of A is 17. Okay. Well done, Tolana. That's really, really good work. Okay. So now we've just got to keep an eye on the time because we've got a quiz as well tonight. Yes, in Corsinati, we're still going to do the quiz tonight. Let's just see who's got a hand up at the moment. Okay, Takalani, you've got your hand up at the moment, and I want to know, can you work backwards to work out what B is? Takalani? Okay, I'm going to try somebody else. Ranghuato?
The answer is 20.
The answer is 20. So in other words, 20 had to go in.
Yes.
Okay, so Ranghuato, are you telling me that this number over here needs to be 20?
Yes, I did it like this. It's 20 times 1.
It's quite right. Perfect. Perfect, perfect, perfect. I just wanted to check that that was indeed what you were telling me. Well done. That's really, really, really good. Okay, now just give me 1 second. I just want to check. Yeah. Masizazi. In number 3. Let me just get rid of this.
Yes, teacher.
There we go. Now I can hear you. Okay, so Masizazi, you're going to tell me, first of all, in number 3, what is the rule?
The rule is -3, -3.
Okay, but tell me what I must write. So in other words, take input and then do what with -3? So in order to calculate your output, what do I have to do to the input? I have to you are on the right track. I've got to take my input and I've got to times it by?
Times it by 2.
How? 2? No, I can't times it by 2. If you have a look here, okay, so these are all consecutive numbers, -2, -1, 0, 1, 2. What's the difference? What's happening each time? Okay, to get from 10 to 7, I had to take away 3. Okay, and then when I go from 7 to 4, I've got to take away another 3. And then when I go from 4 to 1, I've got to take away another 3.
3.
So good. So what am I going to times my input by?
3.
-3.
Yes, ma'am.
Okay, all right, but that's not the end of the story, okay? Because I can't just times by -3 and get my output. So I've got to go and see if this works. So let's take something that's a little bit easier. Let's pretend 1 goes in. So 1 times -3 is what?
1 times -3 is 3.
How? 1 times -3 is not 3. 1 times -3 is? Someone said it. Are there other people in the back there with you, Masizazi?
Ma'am, it's -3.
It is. Good. But do we get -3 out when 1 goes in?
Yes, ma'am. Can you please repeat the question?
Okay, what do we get out when 1 goes in? I've drawn a big purple circle around it. We get out?
1.
Indeed. So now you've got to take -3. And what are you going to do to -3 in order to get 1?
You have to minus it.
Okay, you're sitting at -3 on the number line. There's -2, there's -1, there's 0, there's 1. Okay, so if I'm sitting here, which direction do I need to go? Right or left?
Right.
Right. How many places right do I need to jump?
4.
1, 2, 3, 4 places to the right. So I have to plus 4. Okay. So now can you tell me what my rule is?
It's -3 plus 4.
Okay, so times input by -3 and then plus 4. Very good. Okay, nice work. Well done. Okay, Motibang, can you tell us what A is supposed to be, Motibang?
Ma'am, I think my answer is wrong because I did it wrongly.
It's okay. Even if your answer is wrong, it doesn't matter. Tell me what you did to get A.
Ma'am, my rule was wrong. I just said -3 plus 2.
Oh, okay. All right. But now that you know that the rule is times by -3 and plus 4, can you tell me how we would work out A?
Okay, ma'am. 18 minus 3 is 15.
Oh, but hang on a second. You're timesing by -3, Motibang. You're not just taking away 3.
Oh.
You've got to say, because remember, this is our input, and we've got to times it by -3. So if we've got 18 and we times it by -3, what would we get? Do you know?
No, ma'am.
Oh, it's okay. So on the side, you can work out what 18 times 3 is using short multiplication. So 3 times 8 is 24. So I'm going to put down my 4 and carry my 2. 3 times 1 is 3 plus 2 is 5. Okay, but if I'm multiplying a positive number with a -1, the sign of my outcome has to be negative. Do you remember our course on integers, Motibang, where we said a positive times a negative is a negative?
Yes, ma'am.
Okay, and then remember we were still working with integers. If we're now sitting at -54 on the number line and I plus 4, where will I end?
50.
At -50.
-50. So
-50. Okay, good job. Well done. All right, so what I think I'm going to do is I'm going to have to stop there, unfortunately, grade 7s, just so that I can leave you guys with a little bit of time to go and do the quiz, because there's a few people who are saying, is it quiz time? And they're so excited to do it. So I'm really pleased to hear that. Thank you so much for a really, really lovely lesson. It was wonderful to have you all here with us again. And then please remember to join Kat and I next week, because we're going to be doing some revision of the term 2 work. Okay.